Good afternoon, everybody, or good morning to those of you in Calgary who are joining us. My name is Brent Peltola. I am the Executive Director of Partners in Research Canada, and I will be your host for today's live event in recognition today of the International Day of Women and Girls in Science. Our guest is Magdalena Wierus. Magdalena joined the Canadian Space Agency in 2009 as a software systems engineer for the Canadian robotics contribution to the International Space Station program. She also worked as a project manager for the same program. She now supports the space utilization sector within the CSA as a project engineer on the new RADARSAT Constellation Mission and is the deputy lead for the Junior Astronauts campaign. So welcome to PR live event and look forward to your presentation, Magda.
Thank you so much. Thank you for the great introduction. So I'm going to open up the slide presentation that I have. As you mentioned, my name is Magdalena Wierus, and currently I am a project management engineer here at the Canadian Space Agency.
Sorry, Magdalena, I'm just going to interrupt you. We do have your notes version.
Oh, okay. All right.
Just
let me then just try and, I wonder if this is the right one.
Yeah, that looks good.
Hopefully it is the right one. Okay, so let me get my notes in order here then. I apologize. Okay, so it's not advancing. Let me see. Okay, there we go. So it's a nice picture of the Earth. I just wanted to talk to you guys today a little bit about my background and sort of where I came from. I was born in Poland. I came to Canada as a young girl. And just as you all are there, I went to school in Ontario, actually, and was really, really interested in a lot of tinkering. So I really liked to go and go out and fix the car with my dad, or try and put something together, playing Legos. Those were my interests. From that, I sort of progressed and did well in math and sciences. And then looked at what I could do with that, what would be an interesting path for my life to take and for my career. And loving challenges, I sort of went and looked at engineering. Engineering kind of encompasses all facets of mathematics, sciences, the arts as well, given that you're involved in the design of something as well. So I went into engineering at the University of Toronto, engineering science. They're specialized in aerospace engineering, and started my career off actually doing more work in the aeronautical industry. So with aircrafts, I did some control systems engineering to control the temperature and pressure in aircrafts. After that, sort of space kept calling me, and I went ahead and I did a master's at the International Space University in Strasbourg, France. And from there, I feel I kind of had a foot in the door that gave me an outlet to show myself at the CSA. In the interviews, got in, and as was so well summed up, I started my career here with the Canadian contribution to the International Space Station. So what you see on your picture there is the Canadarm. On the end of the Canadarm sticking out there, that is Dexter, SPDM, special dexterous manipulator, special purpose dexterous manipulator, sorry. And there you can also see that it is attached to the space station on the mobile base system, so MBS, that travels along the entire space station, and it's able to transport the arm, Dexter, or other supplies across the space station. So here we have another view of the arm, and the arm actually has a special attachment where it can hold an astronaut in place when the astronaut is doing work on the International Space Station, or when he's here trying to take a great picture of himself looking down on the Earth. Canadarm II is 17 meters long and was extensively involved actually in the assembly of the International Space Station. So Canadarm II, it kind of lends a helping hand to perform space station maintenance, move supplies, equipment, astronauts, as you can see. And also in the recent history, we've been performing sort of cosmic catches. So catching the visiting vehicles that come up to the space station and then docking them into the International Space Station to provide resupplies to the astronauts and to the crew there. If we move on, this little guy, which what I mean by little is 3.7 meters tall, probably a lot taller than it looks. This is Dexter. And so Dexter is there, he has two arms. And so those two arms allow him to do many different things that the big arm wouldn't be able to do. So for example, if there's a battery change out, Dexter can grab the space station with one arm to provide some stability, grab a battery with another arm, remove it, put it down into a specific location, pick up a new battery and do a replacement on the exterior of the International Space Station. So what that does is it helps the astronauts out. Astronauts don't necessarily need to go out and do some of these tasks anymore. Dexter is able to do that. He actually has the ability to move his arms in 7 joints. They can move up and down, go from side to side, and rotate. So this actually means that Dexter has more motion in those arms than a human arm can complete. Human arms cannot go and rotate all the way around. It would be painful. So here we have the International Space Station. Just to give you guys a bit of a context, it is about 5 hockey rinks wide and a bit longer than 1 hockey rink. Hopefully we have a lot of hockey players out there in the audience. And right now it has a permanent crew from between 3 and 6 astronauts that come onto the station. Those astronauts come from NASA, which is from the United States, ESA, so from Europe, Roscosmos, which is the Russian space agency, JAXA, the Japanese, and CSA, so Canada. We most recently experienced David Saint-Jacques in space, which was very exciting for us over here. So from that life, I transitioned and I took on a new challenge working with satellites. So the Canadian Space Agency works on Earth observation satellites to help us understand our Earth, to help us manage the big country that Canada is from coast to coast to coast. And so our most recent addition to our Earth observation satellite family is this, the RADARSAT Constellation Mission. So this mission contains 3 satellites. They orbit the Earth every 90 minutes or so. And so we have the ability to revisit some of the places in Canada up to 4 times a day, and all of Canada at least once a day. The satellites can cover about 90% of the world's surface. And it's been really exciting to work with these satellites. They're right now up in orbit. They launched in June 2019. And so we've been working on getting them up and operational, and we've been able to declare the operations of RCM active as of the beginning of this year, I believe. So why do we need Earth observation satellites? There's a lot of things that we do with them. So RADARSAT Constellation Mission, or RCM, we're able to detect different crops. So farmers are able to monitor their crops a lot better. We can look at soil moisture. So the farmers know when they need to water the plants or when it's too wet. Another thing that we work on is emergency response. So in the middle there, you see people affected by flooding, and RCM is going to be able to show those emergency responders what happened, what the difference was in terms of water levels, and maybe we'll be able to better respond and better anticipate a flood coming, so that we can get people out of the way earlier rather than having to rescue them. Another thing on the bottom right, you see sort of the coast, and what happens is over time the coast erodes or changes over time, and so RCM being able to get those daily revisits of Canada, daily pictures of Canada, we'll be able to track how our country is changing and what's happening to it. Same thing with the icebergs. So we all know about climate change. We've all been learning about that. We're able to monitor the ice a lot better with RCM. One of the reasons is to help ships navigate within the ice, but also we can take some action on climate change as well. So RCM is really, really exciting and really important to sort of our future and your future. So that's a fun project to be on. So I hope that I've changed a little bit about what you think a space career is. It is not only astronauts. It can also be an engineer like me, a health scientist. So there are doctors and physical therapists and trainers that work with astronauts as well here at the Space Agency, or work on research that helps to understand what's happening to us on Earth. Happens to astronauts in space a lot faster in some cases. So they're working on research that develops or understands those causes of aging better. Space scientists like geologists, astrophysicists, technicians, technologists, there's an endless array of careers in space. Here we have Girls of Science because we have the International Day of Women and Girls in Science, but this is applicable obviously to boys as well. So we're not just saying girls can do it, but we are saying that girls can and do all these things as well. So what does the future hold? Is it interesting for you guys to think about a career in space? Personally, I think so. Canada announced last year that we're participating with NASA to put up another sort of Canadarm II up into space, into orbit around the moon. That space station that's going to be orbiting around the moon right now, it's called Gateway. And so we're contributing to that. We're also looking at contributing a lot of medical experiments that might be done out there to understand better sort of deep space and longer space duration missions. And if you see out in the very far sort of viewpoint of this picture, you can see Mars. And why are we going out to the moon? Well, because the next destination is probably going to be Mars. And so the astronauts and the people that are going to be working on those missions are probably the people that are right there in the room, you guys, sitting there thinking, maybe this is a career that I'd be interested in. Maybe it's something that I want to learn more about. So let's learn more about it. The CSA is actually right now in the midst of our Junior Astronauts campaign. Hopefully you guys have heard about it. We're recruiting, and what we want junior astronauts to show you guys and to teach you is sort of what it takes to be an astronaut, but also what it takes to be a space scientist. For astronauts, the main skill sets required are science and technology, fitness and nutrition, and teamwork and communications. We've broken the activities down in those 3 streams. And I don't know if some of you have already participated in some of these activities, but your teachers or your organizations like Scouts can sign up. And you guys can sign up and get all of these wonderful activities provided to you. And if your school or your organization runs these activities, they will be able to put their name into a draw to win a astronaut or space expert visit at your school or at your organization. So the more streams you participate in, the more chances you have to win, up to 3 chances per school or per organization. So we'd really, really like to put out sort of a call to action right now to all the teachers that are listening to go sign up, go figure out if these activities work within the curriculum. We have tried to make some adhere to some of the space curriculum that happens, we know, in grades 6 and 9 on average in Canada. And
All right, we seem to have frozen for a moment here. Hopefully we will get Magda back with us in a moment. There we go. Sorry, we had a little bit of a freeze in our audio and our video, Magda.
Uh-oh.
That's all. That's technology. That happens.
We can send people to space, but so hopefully I'll just go over the call to action again for the teachers, because I think this is important. We have these easy to do activities that we've developed with space experts, we've developed with fitness experts that sort of center around a space theme. And we'd really like teachers and educators and youth organizations to sign up and try and run these activities with your group. And what that gives you is an opportunity to win an astronaut or space expert visit. We'll be sending, as I mentioned, astronauts all across the country. So you shouldn't expect that just one province will win. We are trying to get winners. We'll be pulling from all provinces and territories that do apply. So you may have a good chance to win if you are one of the ones applying from your province and territory. So I really would urge teachers to take a look at that. And one of the other reasons to take a look at that is that the CSA this summer is planning a junior astronauts camp. So this camp is for students that are right now in grades 6 to 9. And those students, in order to be able to apply to the camp, need to complete one activity in each of the 3 streams that I mentioned before. Having completed those, there's also a video that you get to put together and say why you would be a great junior astronaut at our camp. But ultimately, it is also a random draw going across country. So by province and territory, we'll be drawing 4 names from each province and territory to come join us during the summer here at the CSA in Saint-Hubert, Quebec. The travel costs will be covered by the Canadian Space Agency. The living costs also covered. So it's a week of camp that's going to put you in touch with engineers, scientists, astronauts for space training. We'll be doing a lot of different super fun activities designed again by our space experts. So things that they do on a regular basis that they think are really, really interesting, they want to share with you. And so we want to share with you as well. So parents have until March 29th to submit the entry. So your parents need to sign you up. But also teachers, you would be helping your students be able to sign up to this camp if you run an activity, even in at least one of the streams. So the camp is going to be between August 10th and August 14th of this year. And so I'd really, really encourage all of you to take a look, go on the CSA website, take a look at our camps, take a look at what we have available, and I guess I'll open the floor up to questions now, if there are any. Thank you for allowing me to speak to you today.
Fabulous. Thanks, Magda. I just ended your screen sharing so we can get to a few questions. So we have a few questions to begin with about the Canadarm and the different projects of Canadian use of robotics. Were you involved in Canadarm I?
I was not involved in Canadarm I. No, that predates my time at the Canadian Space Agency. But the technology that was on Canadarm I was definitely a basis for the design and the technology that was used on Canadarm II. So Canadarm I was on the space shuttle, as we know, and it also helped astronauts in space while putting together different items in space, doing repair work, things like that.
Okay, that's cool. Question from Calgary. How can you tell moisture from space? So this is a RADARSAT question.
That is a detailed question. So what it has to do with is the depth of the reflection that happens. You need to also understand, I guess, the science of soil. And RADARSAT is an active sensor. So what it does is it sends down a beam that then is reflected off of whatever it is that it hits, and it comes back up to the satellite. Depending on the amount of moisture in the soil, it will go down farther or less far. And we need to know what we're sort of expecting that depth to be and that distance to be in that area to understand what the relative soil moisture is. And so there's some ground truthing or checking on the ground what that soil moisture is to be able to correlate it and put it into a mathematical matrix equation that can then provide you back an answer for a much larger area of what the soil moisture is within that entire area.
So that's a really good practical demonstration of why there's multiple jobs involved in space work, right? I mean, you've got somebody who's actually going onto the land to help with some of this testing.
That's right, yep.
When you talked about Dexter, I think it was Dexter, is Dexter catching the spaceships, or is that Canadarm II?
No, so that's Canadarm II, that's catching the spaceships. Dexter is really used for more intricate tasks. So change out of batteries or change out of cameras. It's able to do a lot finer detail in terms of motion and movement and capturing, grabbing certain items and replacing them. The other thing that the technology of Dexter will help with, for example, something that's being looked at in terms of satellite servicing. So satellites that are going around the Earth, their main life expectancy issues are with fuel. So if there's a way that you can get a machine or a flight to refuel that satellite or to fix something on the satellite, you could extend the life of those satellites and not have as many satellites out of commission in space. So the technology in Dexter is being used towards those research and development work for satellite refueling and recommissioning, I guess.
Okay, so for a point, as a point of reference then, if Dexter was doing a battery change, how long does that take?
It's a good question. I think they usually plan between 4 to 6 hours. It's very, very slow. You don't want to be watching one of these in actual time because any minute error could cause a problem on the International Space Station. You don't want that. You have a pressurized, very soft sort of shell, keeping these astronauts safe and secure. And if you were to do something out of the ordinary, pull too hard, hit something with one of the hands, you could cause damage that may put those lives in some sort of jeopardy or a security concern. So everything is done very slowly. Motion is done slowly. Every step is checked that the motion completed correctly. There was no deviation, things like that. We have cameras that look from 3 angles or so at least to make sure that we have a proper assessment of where that robotic manipulator went and if it did what it was told to do. So it's great. Actually, we have Dexter is now really only controlled from the ground, and there's many ground controllers that are here at the CSA in Saint-Hubert, Quebec. We're sort of a trusted ally that is allowed to control our own components from our own offices, and we relay it back to NASA. So we work with them, but we can work remotely. So it's
excellent. We have a question asking about how many people in total have been to space, and maybe given the theme of today, maybe given
I'm looking back here because Magali, my communications specialist, is just looking it up.
and
Googling.
And maybe we can talk about women in space, given the theme for today. I know we've had Canadian female astronauts.
We have, so we've had 2. We had Roberta Bondar and we had Julie Payette, who's now the Governor General of Canada. Jenny Sidney is now, she just graduated from her astronaut class, which was very exciting. So now she is a full-fledged, ready to fly astronaut and waiting for a space flight. One of the sort of perils of being an astronaut is you have to wait for your turn. There's not very many seats to go up there, and there are enough willing astronauts where you have to wait for your turn. The turn comes also based on the amount of support and sort of monetary financial contribution that the different governments put towards, right now, the International Space Station, but in future to Gateway and things like that. So it's on a percentage basis how we get our flights. So we have numbers. We have 565 astronauts that have been to space so far, 9 Canadians on 17 missions. And of those 9 Canadians, of course, 2 were female.
Excellent. Thank you for the support off screen. That's fabulous.
Yes.
You mentioned the Lunar Gateway, and I know that's a big part of what we're doing in the Junior Astronaut Program. Why the Lunar Gateway? What's the advantage to this structure over the ISS?
It's a very good question. One thing is it's farther. So the technology that we need to have out in the Lunar Gateway must be a lot more sophisticated than what we have in ISS. ISS, we have very little, if almost no delay, very little, if no delay in terms of communications with the ISS. Lunar Gateway, I don't want to make a mistake, so I won't say how long, but there is a more significant delay in terms of communication. So you have to rely more on AI. So the robotics out there will have to make certain decisions on their own. They won't have 3 cameras and humans looking at what's happening, or even astronauts all the time looking at what's happening and making sure that things are not going awry. So the technology there helps us then develop technology that we will use even farther out into deeper space. So it's a bit of a stepping stone. We've been to the moon before, but we've never sort of spent a lot of time there. the effects of radiation out in space on our astronauts as well needs to be studied a little more. What happens to the human body when it's out in deep space, but also what happens to the human mind. So how do the astronauts talk to each other and live with each other for such a long period of time? We're doing that on the ISS, but being farther away, maybe there's and having different constraints, maybe there's a different effect there. So there's a lot to learn in order for us to be able to go out, say, to Mars and be safe and be ready for those types of initiatives. So
very good. So back to the ISS, we had a question in the chat window asking how many people are allowed to be in the ISS at one time.
That's a good question. Right now, up to 6, just because what they want is they want to be able to bring all 6 out as needed and safely. So there's always one Soyuz capsule that can carry 3 people. That's up there as an emergency escape vehicle. And when another crew comes up, they bring up another vehicle with them. So there's always 2 vehicles that can take down the 6 crew at one time if, for example, there's a meteorite strike on the ISS, and say all of a sudden there's an emergency, they don't have, it may lose pressure or start to lose pressure. They will put, and they have done this in the past, where they put the astronauts into the Soyuz capsules ready to come down. And then they do checks on the ISS. Is everything okay? Can we stabilize certain systems? Can we shut off or close certain compartments to make sure that the pressure is stabilized? So really 6 right now, but if and when sort of the American systems are able to bring up more astronauts and bring down more astronauts, that's all just going to depend on, I guess, the living, the available oxygen, the available food and things like that. But I think it's quite tight as it is with 6, but they might be able to increase it by 1 or 2 if they'd like.
Great.
It's just the safety of the astronauts that comes first and foremost.
Excellent. So we're getting close to the end of our time, but we did get one more question that popped in, and this is the one I always like to end with anyways. So what type of education does it require to become an astronaut?
Oh, well, astronauts come in all shapes and sizes, and all educational backgrounds as well. They're very much go-getters. They're active in their community. I would say that looking into cadets might be one way of, air cadets in Canada, might be one way of sort of starting to get exposed to some of the requirements of an astronaut, because they do need to learn to fly a plane. They do need to understand the mechanics of it all. But if you look at David Saint-Jacques, he was an engineer. He became a doctor. And so that was his path. If you look at Jeremy, he went into the Air Force and was a fighter pilot, sort of took a similar path to what Chris Hadfield did. So I would say math and sciences are definitely important. And so you need to have those background or that background. But more and more, I think different backgrounds, different skill sets are going to be needed as we go out farther, as we try and progress our exploration of space. I'd recommend whoever's interested also to go on to the CSA website, because we do have sort of the backgrounds of all these astronauts, and even really interesting videos about the latest astronaut campaign and what they had to go through, the different tests they had to do, and sort of the different paths that they took to try and even apply. But it's it's a big application process, and Canada doesn't have that many astronauts. So it is a bit tough to make sure that you can become an astronaut. But I would definitely encourage everyone to try and to do your best. And if you don't become the astronaut, you can always work in space as well and work to support the astronauts that do go out there and do amazing things on our behalf. So
That's fabulous. That's a great message to end on. So thank you very much for your time today, Magda.
thank you. Thank you for the opportunity to speak to you guys today.
And thank you to all of our classes who joined us today. Just a reminder that there is another junior astronaut webinar tomorrow featuring Elisa Dong from Western University. And Elisa is going to talk about her research into earthquakes, its application to seismic activity on the Martian planet, and the implications that that has for space research. So I hope you can join us tomorrow and for some future junior astronaut webinars. Again, thank you very much and enjoy the rest of your day. Goodbye.
Thanks, guys.